solving simultaneous equations where you have a linear and a non-linear, like a quadratic, with adamonlinetutoring. Here's the beginner question, which is one of the easiest types of questions you can get on this topic. Solve the simultaneous equations. They've told us that y is equal to x squared and y is equal to 9x minus 18. Notice how you have an x squared term. This means that it's not a linear equation, it's actually a quadratic equation. If it's not linear, we won't be able to use the method in previous videos of elimination, where we make the coefficients of the variable the same and add or subtract using different signs add or same sign subtract. Instead, we'll have to use substitution. Notice how they've told us that y is equal to x squared and y is also equal to 9x minus 18. That means that both of these expressions are equal to y, and therefore we can substitute and make them equal to each other. Therefore x squared is equal to 9x minus 18. Now we have a quadratic in x, we can make equal to 0 and solve to find our solutions for x. To make equal to 0, I'm going to subtract 9x from both sides and add 18 to both sides. So x squared minus 9x plus 18 is equal to 0. We'll be able to solve this quadratic by factorizing. I'm looking for numbers that multiply to give me 18 and add to give me negative 9. That would be negative 6 and negative 3. If x minus 6 bracket x minus 3 is equal to 0, then one of these brackets must be equal to 0. If the first one was equal to 0, x minus 6 equals 0, then x would be equal to 6. But if x minus 3 was equal to 0, then x would be equal to 3. Now I have my solutions for x. X is 6 and x is 3. Now we need to find our corresponding y values. So when x is equal to 6, I can substitute this back into one of the original equations. It doesn't matter which one, but I'm going to go with y equals x squared. It's a little bit easier. So when x is 6, y would be equal to x squared, or y would be equal to 6 squared, which is 36. And for the other solution, when x is equal to 3, y is equal to 3 squared, which is 9. And those are my two answers. When x is 6, y is 36, and when x is 3, y is 9. Next, we have the intermediate question, which has a slight increase in difficulty, but can be solved in the same way. If we're told that y is equal to x squared plus 3x plus 7, and y is also equal to x plus 10, we can make these two expressions equal to each other. X squared plus 3x plus 7 is equal to x plus 10. Make equal to 0 so that we can solve to find our solutions for x. We can subtract x and 10 from both sides. So we have x squared. We already have 3x on this side, so subtracting x will leave us with 2x. And we already have 7 on the left hand side, so subtracting 10 from both sides will leave us with negative 3. And this is equal to 0 now. This quadratic expression does factorize, so we're looking for numbers that multiply to give us negative 3, but add to give us 2. Those numbers would be positive 3 and negative 1. So for these brackets to be multiplied by each other and to give us 0, it must mean that one of the brackets is equal to 0. If x plus 3 is equal to 0, x would be equal to negative 3. And if x minus 1 was equal to 0, x would be equal to 1. Find our corresponding y values. We'll start with when x is negative 3. Substituting this back into one of the original expressions, it looks like the one at the bottom is a little bit easier to use. Y is equal to x plus 10, so therefore y would be equal to negative 3 plus 10, which is 7. And when x is equal to 1, y would be equal to 1 plus 10, which is 11. Therefore, our solutions are when x is negative 3, y is 7, and when x is 1, y is 11. Lastly, we have the advanced question, which is most similar to some of the more difficult types of questions that you're likely to see in an exam. Notice with this question, it asks us to leave our solutions to 2 decimal places, and the use of a calculator is permitted. This will help us a little bit later on in our working out, but before we get to that point, the method would remain the same. Y is equal to x squared and y is equal to 4x plus 7. So let's make these equal to each other. X squared is equal to 4x plus 7. Subtract 4x and 7 from both sides. x squared minus 4x minus 7 is equal to 0. The reason a calculator is permitted is this quadratic that we have here will not factorize. Instead, to find the solutions, we'll need to use the quadratic formula. We can find our solutions for x by doing negative b plus or minus the square root of b squared minus 4ac all over two lots of a, where a, b, and c represent the coefficients of these separate terms of the quadratic. X squared is the same as 1x squared, so the coefficient is 1. B is negative 4, and c is negative 7. Substitute these into the quadratic formula. We start off with negative b, that's negative 4, which is actually going to be a positive 4 at the beginning. Then we have b squared. Any of the terms that involve squaring, when you have negatives, you need to use brackets, otherwise your calculator will miscalculate this. And we have 4 lots of a, which is 1, multiplied by c, which is negative 7, all over 2 lots of a, which is 2 lots of 1. Type this into your calculator, starting with a positive here, and that will give you your first solution for x, which is 5.3166. Next, retype or edit what you've written on your calculator to include a subtraction instead of an addition, and that will give us our second solution for x, which is negative 1.3166. Now we have our solutions for x, we can find the corresponding y values. I'm going to substitute into y equals x squared. So y is equal to 5.3166 squared, which is 28.266. And lastly, when x is negative 1.3166, y would be equal to this squared, which is 1.733. We were asked to round our answers to 2 decimal places. Notice how I've left this until the end to avoid any rounding errors throughout. 2 decimal places on the first one would be 5.32, and for the y value would be 28.27, and for the other solution, negative 1.37 and 1.73. So when x is equal to 5.32, y is equal to 28.27, and when x is equal to negative 1.37, y is equal to 1.73. Before you go, have a look at the solution which I've created for a question similar to one of the intermediate ones. I may have made a couple of mistakes along the way. Let's see if you can identify what they are and either tell me what they are or see if you can make some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with maths or finding topics difficult, you can subscribe and turn on notifications to receive regular updates about new video tutorials. Don't forget to visit my website adamonlinetutoring.com for a full searchable list of all topics with exams, questions and solutions. You can also visit me on social media using the handle @AdamMathsTutor on Instagram, TikTok, Facebook and Twitter. All links in the description below.